Okay, so today we're going to talk about speed and velocity, which is chapter 11.2 in the book. So speed is a word we all know, but the definition of speed is that it's the ratio of the distance an object moves to the amount of time it takes the object to move. Basically, when you hear the word speed, you should think, how fast? Is it moving fast or is it moving slow? If it's moving fast, it's covering a large distance in a short amount of time. If it's moving slow, it's covering a short distance in a long amount of time. And there are two types of speed. There's average speed and there's instantaneous speed. Average speed is computed for the entire duration of a trip from point A to point B. So it took me 2 hours to drive 100 miles, so my average speed was 50 miles per hour. I took the 100 miles, my distance, divided by my time of 2 hours, and I got 50 miles per hour. Instantaneous speed is measured at a particular instant. So, at one point on the highway during this trip, my speedometer read 65 miles an hour. So even though my average speed for the whole trip was 50 miles an hour, I wasn't going exactly 50 the whole time. My instantaneous speed at one moment was actually 65. But my average speed tells me sometimes I was going a little faster than 50, sometimes I was going a little slower, and when we average those, my average speed was 50 miles per hour. So the average speed can be found by taking the distance traveled by an object and dividing by the time it took to travel that distance. And we can measure the instantaneous speed of an object with a speedometer, and we can calculate the average speed of an object with an equation, like I just showed you. But we can also describe the speed of an object through a graph. And this is exactly what we did with our buggy lab. And we found that as we graph the distance an object travels versus the time it takes to do that, the slope of that line is the speed. So let's look at some examples. If we look at this distance versus time graph, we can see that this slope is steady. It is not changing. What that means is this object will travel the same distance in each second. It's not speeding up or slowing down. So this straight line indicates a steady speed. If we compare this to the graph next to it, these are both straight lines. They're both showing us that the speed is not changing. However, the speed of this object is much faster than this object. And we know that because it's traveling a farther distance in the same amount of time. Now, we can actually take this information and translate it into a velocity versus time graph. So if we look at the slope of this line, it is steady and positive. It's sloping upward. So the way that we draw that is a steady line in the positive part of our graph. So if this were negative, sloping downward, our graph would instead be drawn underneath the time axis, and we would have to extend our y-axis down here. Now, this graph is also steady and also positive, but it is a steeper slope, and therefore we draw it higher up on our velocity axis to show that it is a higher steady velocity than this one does. Now, velocity is a description of both speed and direction of motion. So it's a vector just like displacement is. So out of these four examples, 10 miles per hour, 30 meters per second east, 0.01 feet per minute to the left, and minus 80 kilometers per hour, only the first one of these is considered a speed. This one tells us how fast we're going, but it says nothing about the direction. The other three are considered velocities. And that's because they tell us the direction of travel. In the 30 meters per second, we're traveling east. In this one, we're traveling to the left. And in this one, the negative will actually tell us the direction of travel as long as we establish a frame of reference first. If I say traveling up the road toward school is positive and down the road away from school is negative, we are indicating with this minus sign that I am moving at 80 kilometers per hour away from the school, down the road. So when we define velocity, often we talk about having a positive and negative velocity. And in order for that really to hold true, we need to make sure we establish our frame of reference first. Now, just like with displacement, velocity can be represented by an arrow. And this is true of all vectors, all measurements that have a number and a direction associated with them. So the length of the arrow represents the size, and the direction of the arrow represents the direction of motion, or whatever thing it is. So if these are velocity arrows, this arrow represents an object moving very fast upward. This one represents an object moving slowly to the top right-hand corner. And this object is moving at a medium speed to the left. So we can use these arrows to help us visualize the motion of an object. And we can also use them to help us figure out vector addition, or the addition of velocities. So when an object's movement involves more than one velocity, we add them, just like we did with displacement. So an example of this is, let's say that I'm driving and I drive down to the end of the school driveway at 20 meters per second. And I get there and then I remember, darn, I forgot my grading. So I turn around and I come back at 8 meters per second, and then I speed up a little less than halfway there and make the rest of my journey at 12 meters per second. So 20 meters per second there, 8 meters per second for a short time back, and 12 meters per second for the rest of the way. If I take the average of these, the way that I do that is I do 20 plus 8 plus 12, except I need to include distances and directions here. So if I move at 20 meters per second down the driveway, I can call that negative. We'll say down the driveway and away from school is a negative direction. Coming back up, those are positive. So the way that I add these together is I have negative 20 plus 8 plus 12. And when you do all that math out, you get 0. So my average velocity for that trip was actually 0. And the reason why is because velocity is considered a displacement divided by time. Speed is distance over time, but velocity is displacement over time. So just like with displacement, if I go on a trip and come right back to where I started, my total displacement is 0 because I haven't moved anywhere. And if my displacement is 0, it does not matter how long it took me to do that trip, my average velocity is going to be 0. So this is going to sound weird because we think of velocity as movement, and there was movement involved. But when we talk about velocity and displacement, we have to cut out everything that happens between point A and point B and just look at where we started and where we ended. So here are your homework questions. Please have them ready for tomorrow.